Example 2. Graph each linear equation. We're going to be referring to figure 5, 6, and 7 to show the graph. Part A. The equation y equals x minus 4. Again, this is a linear equation, so we need at least 2 points for each line that we're going to construct. We're going to primarily emphasize intercept, although in some cases we may have other points other than intercept. In the case of y equal to x minus 4, part A, we can let x equal to 0, then y must equal 4. That gives us the y-intercept. Then we can turn around and let y equal to 0, and then solve for x and get x equal to 4. So here we have the x and the y-intercepts. They're the two best points probably to graph this straight line. So if we look down at figure 5, line A, we will see those 2 points, and that represents our graph. Next, let's go to part B, linear equation y equals minus x plus 5. Again, we need at least 2 points, so we'll first try to get the intercepts. To get them, we can let x equal 0 and solve for y, which is 5. And then we can turn around and let y equal to 0 and solve for x, which is also 5. So we have 2 very, very good points in those intercepts. Consequently, we can go to the graph, figure 5 once again, and look at line B, and we'll see those 2 points that we just described. 5, 0, and 0, 5. There's our line B. Next, we'll go to equation C, which is x minus y equals 6. Again, using our intercept points, we get 0 minus 6 and 6, 0. Now, as we go to this graph, we'll be looking for line C in figure 6. It'll contain the 2 points that we just described, and you can see the straight line there. Then we'll move to equation D, which is y minus 3x equals 0. We can rewrite that equation if we choose to y equals 3x. Either way, we let x equal to 0 and solve for y, which is 0, and so the x and the y-intercepts are the same here. Consequently, we need at least 1 more point. So this time I'm going to assign x a value of 1, and we find y to be 3. So we have the 2 points, 0, 0, which is the origin, and the point 1, 3, and we'll be able to decipher the line. It should be line D, and you can see line D as we have it described here. Then we'll move to E. E has the equation 3x plus 7y equals 14. Again, we'll get the intercepts. We can get the y-intercept by letting x equal to 0, in which case we get y equal to 2. To get the x-intercept, we'll assign y a value of 0, and we get x equal to 14 over 3. So we have those 2 points, and then we'll go to the graph, which is E, and you can see the line that we discern from those points, line E. Next, we'll proceed to equation F, which says x equal to minus 3. Remember, there's no y variable. Consequently, this line or this graph should be a vertical line, and it should be a vertical line through x equal minus 3. Consequently, we can assign any value we want to y. So we will emphasize these 2 points, minus 3, 0, and minus 3, 5. Either way, we'll get this vertical line for F, which you see there, right through x equal minus 3. Next, we proceed to G, which is the equation y equals 4. Notice once again, no x variable in this equation, so we only have y. So y is fixed. It must always take on a value of 4, allowing us to assign any value we wish to x. So let's go with these 2 points. X equal to 0, y equal to 4, and x equal to minus 3, y equal to 4. Either way, remember, we're going to get a horizontal line right through the value y equal 4. And that would be equation G, line G. Okay. Then we have equation H, which is x minus 1 equals 0. Remember, there's no y variable here, so y can take on any value. But what we can do is isolate x so that x is always equal to 1. So the 2 points we've chosen to highlight are x equal 1, y equal to 0, x equal 1, y equal 3. So let's look at the graph. And as you can see, there's that vertical line right through the point we indicated. Next we have I, which is y plus 2 equal to 0. Again, no x variable, so x can take on any value, but y will be fixed. It will be the value of minus 2. So we can start with the point 0, minus 2, and minus 3, minus 2. So notice this graph will be a horizontal line going through y equal minus 2. And this will be graph I. There's the horizontal line right through y equal minus 2. Finally, there's J. This equation says minus 2y equal 10. Again, notice no x value, no x variable, so x can be any real number we choose to assign. However, we need to find the fixed value for y. We can do so by dividing both sides by minus 2. So the y value that is fixed is y equals minus 5. So we can choose the 2 points 0 minus 5 and 2 minus 5. But remember, this has to be a horizontal line right through the value y equals minus 5. So as we look at J, we see that there's that horizontal line right through y equals minus 5.